Hello, sir.
Good evening, ma.
Good evening, sir.
Good evening, ma. Sriveda. Remembers the login still somebody? Smita, Anjan, Shanmukh Anjan, Sriveda. Aditi is absent. Aditi, Madhusudan. All of you are getting my voice? No one is giving response.
Yes, sir.
Very good, Anjan. So I think so. They may be joined a little bit late. Okay. So then I'll start the class. So we told that. So we'll start with the nomenclature. So already fundamental concepts are everything is finished. Classification also it is finished. Okay. So organic compounds. All of you, everyone, you having the idea about the classification of organic compounds. So organic compounds are classified into how many types, ma? Organic compounds are classified into how many types? Any one of you, Anjan? Organic compounds are classified into how many types? Actually, organic compounds. Classification of the organic compounds are classified.
Aliphatic and aromatic.
But that is a different. So first of all, organic compounds are classified into open chain compounds, open chain and closed chain is there. Closed chain compound. And this also we can call as a cyclic, and this we can call as the acyclic also. Okay, open chain or acyclic, a closed chain or cyclic compounds. Again, cyclic compounds are classified into two types. What are the two types of the cyclic compounds we are having means? One is homocyclic compounds, homocyclic, and another one is heterocyclic. Okay, heterocyclic. So any one of you can tell me the examples of the heterocyclic compounds? Examples of the heterocyclic compounds. First of all, what is meant by the homocyclic and heterocyclic? Now, homocyclic is nothing but if the cyclic ring is containing carbon atoms means that we can call as a homocyclic. Cyclic ring is containing only carbon atoms means that we can call as a homocyclic. And heterocyclic compounds means in a cyclic ring, one carbon atom is replaced by either nitrogen, oxygen, or sulfur means that we can call as a heterocyclic compounds. Is that clear, Anjan? Okay.
Yes,
what are the examples of the heterocyclic compounds, Anjan? Samhita. Samhita, what are the examples for the heterocyclic compounds? Do you remember this structure?
Yes, sir. Benzene. No, sorry, sir. Sorry, sir.
This. What is the name of this one? This one is sulfur. What is the name of the first one? NH. So this one is we can call as a furon, tetrahydrofuron. So this we can call as a thiophene. This we can call as a pyrrole and pyridine and double bond, double bond, double. This we can call as a pyridine. Okay. Now if you see, you are telling that it is a benzene-like structure. Okay. So pyridine is having the benzene-like structure. Benzene, what is the molecular formula of the benzene? Molecular formula of the benzene, ma.
C6H6.
C6.
Very good, ma. C6H6. That means in the cyclic ring total, how many carbon atoms are there?
6.
6 carbon atoms are there. So that is also we can write like this. So this is the benzene structure. Okay, this is the benzene structure. In benzene structure means one carbon atom is replaced by the nitrogen. In one place, one carbon place, if the nitrogen it is there, means that we can call as a pyridine. So all these are the examples of the heterocyclic compounds. What is mean by the heterocyclic compounds means in a cyclic ring, one or more carbon atoms are replaced by other elements. What are the other elements we are taking means either it may be oxygen or sulfur, nitrogen atom. That we can call as a heterocyclic compounds. Then, what are the, again, homocyclic compounds are classified into two types. Again, homocyclic compounds are classified into two types. What are the homocyclic compounds means? One is alicyclic and aromatic. Alicyclic and aromatic. What is meant by the alicyclic compounds? Is any example for the alicyclic compounds? Any one of you? So this concept is finished or not? Anjan? Veda? This concept is finished or not?
Yes,
Classification
sir.
finished? Huh?
Yes, sir.
Then you're not giving examples at least. Okay. So actually my intention is if you won't give examples with that, I'll understand that I can understand. So either you got or not, that is only the problem. That's why again and again I'm asking. Okay. So alicyclic compounds example.
Methane, like.
No. Cyclic compounds we are talking. Anjan.
Okay.
Cyclic. Cyclic means here cyclopropane, cyclobutane, cyclopentane. Okay, cyclopentane, cyclohexane. All these are the examples of alicyclic compounds. All these are the examples of alicyclic compounds and aromatic compounds. Aromatic compounds, which we can call as aromatic compounds, is actually aroma is a Greek word. Okay, according to the Greek word aroma means it is a pleasant smell. According to the Greek word aroma means here pleasant smell. The substance, the organic compounds which gives the pleasant smell, okay, that we can call as aromatic compounds. So what are the best example for the aromatic compounds means here? One is camphor. All of you have seen the camphor?
Yes, sir.
Anjan, Sriveda, Samhita. Samhita, what is mean the camphor? In home also we can use camphor.
Yes, sir. It's used in puja.
While doing puja and all. At the same time, camphor can be used to the air freshener also. Okay, so it refreshes the air also. It purifies the air also. Okay, and what is another example which we can see daily life means here? Naphthalene. Naphthalene wounds. All of you have seen the naphthalene wounds or not? Naphthalene
sir.
balls we can call. Okay, so naphthalene balls also, they are one of the example of the aromatic compound. These two are daily we are using this in daily life. Okay, so camphor and naphthalene both are they give us some pleasant smell or awkward smell they'll give. Both man.
They give pleasant smell.
Very good man. They'll give us a pleasant smell. Okay, so according to that one, how we can define the aromatic compounds means the compounds which gives the pleasant smell is called as aromatic compounds. Okay, and they burns with smoky flame or sooty flame. Okay, how they burns means here they burns with sooty flame or smoky flame is called as aromatic compounds. So which we can call as aromatic compounds means the compounds which burns, which gives the pleasant smell and which burns with the sooty flame or smoky flame is called as aromatic compounds. Now you got the clarity? Okay, and so chemically to exhibit as a aromaticity, the compound has to follow the three conditions. All of you know what are the three conditions it has to satisfy the aromatic compounds. Okay, again, the letter C means. So the aromaticity means to exhibit the aromaticity means here compound has to be planar structure. Second one, conjugation, conjugation, and third one is Huckel rule. Huckel rule. They have to follow the Huckel rule. What is meant by the Huckel rule? Anjan, what is meant by the Huckel rule?
Having electron 4n plus 2 pi.
Very good, sir. Okay, so if the compound is having 4n plus 2 pi electrons, means that we can call as here Huckel rule. Okay, in this one n is equal to, sir, integer number. You can take as a 0, 1, 2, 3, 4. Okay, for benzene onwards. For benzene and all we can take as a cyclic ring is here 1. N value we can take as a 1. Okay, if n is equal to 1 means total number of electrons present in is here 6 electrons. Okay, if n is equal to 2 means it has a 6 pi, 10 pi electrons. If n is equal to 3 means it contains 14 pi electrons. Just I'm submitting the n value. If you substitute the n value means you will get as here, sir, 6 electrons, 10 pi electrons, and 14 pi electrons. If n is equal to 0, if n is equal to 0 means we'll have here 2 electrons. Okay, so based on that one, sometimes they're asking some questions in the examination part. Okay, so which type of the questions they are asking means here they'll give some example. For example, here cyclopropene carbocation. The given compound is aromatic or non-aromatic or anti-aromatic. You know what is meant by the aromatic, non-aromatic, and anti-aromatic? Samhita or Srimeda. Srimeda, aromatic. Aromatic means if the compound it follows all these three rules means that we can call as aromatic. What is mean by the non-aromatic?
Which does not have this three.
Which does not have Sai Akshit. Okay. So Sai Akshit today is the first class. Is it right? Akshit? Okay. Akshit is not responding. Okay, ma'am. Whether you are giving some answer. What is mean by the non-aromatic, ma'am?
Opposite to aromatic compounds.
Very good. Opposite to aromatic means in out of three conditions, if any one of the condition is not satisfied, means that we can call as non-aromatic. And what is mean by the anti-aromatic? Aditi? Aditi, hi.
Hi, sir.
What is mean by the anti-aromatic, Aditi?
Is it a non-benzyne compound?
Is it?
Is it a non-benzyne compound?
It is non-benzene compound. Why not? We can apply for the benzene compounds also. Anti-aromatic. Sir, what is mean by the anti-aromatic means here? Anti-aromatic means the compounds are contain planar structure, and the second one is they have a conjugation, and third one is they contain 4 and 5 electrons. 4 and 5 electrons. Okay, in this one, sir, n value 1, 2, 3, 4. N is equal to 1, 2, 3, 4. Okay, and it won't be 0. Here, now once you check it out, that we can call as anti-aromatic compounds. If n is equal to 1 means the total number of pi electrons, how much will get? If n is equal to 1 means how many pi electrons it has to be there? 4 pi electrons. If n is equal to 2 means how many pi electrons you will get? N is equal to 2. 8 pi electrons. Now I'll give some examples. Can you please explain me which one is aromatic and which one is a non-aromatic and which one is anti-aromatic? Okay, first one already I given. The given compound is aromatic or non-aromatic? Three examples had given. Sriveda.
Yes.
First example is aromatic or non-aromatic or anti-aromatic. Samhita,
Yes, sir.
what is the answer for this one? First example. The given compound is aromatic, non-aromatic or anti-aromatic. Anjan,
So first one is anti-aromatic.
this one is anti-aromatic. Anjan, once you check it out, Anjan.
No, aromatic, sorry, yes, aromatic.
First one is aromatic, man.
Aromatic, yeah, aromatic.
First one is aromatic. And second one, sir?
Second one
Aditi,
also
second one?
aromatic.
Second one also aromatic.
So
No,
is it anti-aromatic?
Which one, ma?
Second one.
Second one is not the anti-aromatic, it is non-aromatic. Third one?
anti-aromatic.
Very good, sir. It is anti-aromatic. Can I explain clearly how it is aromatic, how it is non-aromatic, how it is anti-aromatic? Okay.
Yes.
Now, first one, Anjan, we told that as an aromatic compound. It is exactly right. So, how it is exactly right means it follows the three conditions. What are the three conditions it has to follow the aromatic compounds means? First one is planar. Most of the cyclic structures are having the planar structure only. Most of the cyclic compounds are having planar structure. Second one I wrote as a conjugation. First of all, what is meant by the conjugation? Now, conjugation is nothing but alternate single bond, double bond, single bond, double bond like that. If you see in benzene, now here you wrote as a one pyridine structure. Alap, you able to see the pyridine structure?
Yes, sir.
In this one, double bond, single bond, double bond, single bond, double bond, single bond. So whenever you get this kind of structure, means that we can call as a conjugation. Sometimes we have to consider charge also. Okay, now first charge is there. After that, single bond. After that, double bond. After that, single bond. Again, you got as a charge now. So whether the given compound is having conjugation or not, alternate it is there or not. Charge, single bond, double bond. Again single bond, charge. Okay. Now it is having conjugation. That means second condition is satisfied only now. And third condition. What is the third condition? Huckel rule. What is the Huckel rule? It has to be contained 4n plus 2 pi electrons. For cyclopropane, n value is equal to 0. For cyclopropane, n value is equal to 0. If n value is equal to 0 means how many pi electrons it has to get? How many pi electrons it has to be there, ma? Aditi, how many pi electrons it has to be there? 2 pi electrons. But the given compound is having 2 pi electrons or not? The given compound is having 2 pi electrons or not? Veda. Sri Veda. Whether the given compound is having 2 pi electrons or not. Samhita.
Yes, sir, it does.
Whether the given compound is containing 2 pi electrons or not.
Yes, sir, it has 2 pi electrons.
How are you telling that the given compound is having the 2 pi electrons, ma?
So there is double bond present. So I think there is.
Double bond means it has a one single bond, another one is here, pi bond. In the formation of the one bond, how many electrons are required? In the formation of one bond, how many electrons are required? Aditi.
2 electrons.
Very good one. 2 electrons. Okay, 2 electrons are required in the formation of one bond. So if it is having one pi bond means it contains 2 pi electrons only, na? Hence, all 3 conditions are satisfied. If all 3 conditions are satisfied means then the given compound is called as aromatic. Okay. And second example. Second example, once you checked out, ma, you can apply the concept only here. You can apply the 3 concepts. Whether the given compound obeys the 3 rules or not. First one, planar structure. Planar structure it is there. Second one, conjugation. Conjugation means alternate double bond, single bond it has to be there. Here single bond, double bond, single bond. After the single bond, immediately get us here single bond only. It is not having charge and it is not having any double bond. That means second condition is not satisfied now. Is second condition is satisfied in the second structure?
No, sir.
No, ma. Then what about the third condition? Huckel rule. Either it is also contain the 2 pi electrons only, na? Okay, it contains 2 pi electrons. So any one of the condition is not satisfied means that we can call as a non-aromatic. Okay, and anti-aromatic. What are the rules for the anti-aromatic means here? One is the planar structure, conjugation, and 4 and 5 electrons has to be there. Okay, 4 and plus 5 electrons it has to be there. Now once you check it out, first one, planar structure is there, and conjugation, single bond, double bond, single bond, and charge also it is there. So it has a conjugation and number of electrons. And what is the charge it is there on cyclic ring? Negative charge or positive charge? What is the charge present on the cyclic ring?
Negative charge.
Negative charge. And then if it is negative charge means that we have to consider it as a 2 electrons or single electron.
2 electrons.
Okay. That negative charges involves the formation of pi bond or sigma bond. The delocalization. So when this negative charge is involved in the formation of the pi bond. Okay. So the total number of electrons present in this molecule is 4 pi electrons. 2 plus 2. 2 plus 2 it is having 4 pi electrons. Okay. According to the anti-aromatic compound conditions, planar structure is satisfied, conjugation is satisfied, and it contains 4 pi electrons. If it contains 4 pi electrons, then the given compound is anti-aromatic compound. Now all of you understood this one? Everyone. Can I give one more structure? One more structure I will give you. Let us see how many members they will give the answer. Either Aditi, okay, either Aditi and John. How many members they will give the answer? Let us see. One example. Yes. In these two, which one is the aromatic and which one is the non-aromatic? So three structures, three examples had given. Three examples. Which one is aromatic and which one is not aromatic? Anjan, first example. Aromatic, non-aromatic, anti-aromatic.
Is it anti-aromatic, sir?
First one is anti-aromatic. Okay.
So I also
Anti.
think it's anti-aromatic.
Which one, ma? Samita.
First one is anti-aromatic.
First one is anti-aromatic. Very good. Next.
Aromatic.
Second one is
Aromatic.
aromatic. Veda. Second one. What is the answer for the second one? Samhita is telling that aromatic. Either it is aromatic or non-aromatic or anti-aromatic. Sri Veda. And for the Aditi. Aditi, what is the answer for the second one? Second one is correct or wrong? Akshit? Then what about the third one? Any one of you, third one.
Aromatic.
Aromatic. Very good. Next. Okay, third one also is here. Aromatic. Third one is aromatic. Third one is aromatic. So now you got the clarity? Sir, first one is anti-aromatic. Because of it has a conjugation is there, planar structure is there, but it has only 4 pi electrons. How many pi electrons are there? 4 pi electrons. But second structure, if you see, means planar structure, conjugation, and it has 6 pi electrons. Okay, it follows the Huckel rule. If it follows the Huckel rule, means that we can call as an aromatic compound. And this one also, sir. In this one, what is the n value means? N is equal to 3. Number of cyclic rings we are taking. Okay, in this one, what we are taking means here. So we are taking as a number of cyclic rings. What is the cyclic rings value? N value means n value is equal to 3. Okay, according to that one, total number of pi electrons is equal to, you will get as here 14 pi electrons. Conjugation is there, planar structure is there, and it has a 14 pi electrons. Whenever it has a 14 pi electrons, means that we can call as an aromatic compound. Now you got the clarity, all of you? Okay. Again, aromatic compounds are classified into two types. You know what? Don't know, I don't know. Again, aromatic compounds are classified into two types. Aromatic What are the two types of the aromatic compounds? Aromatic compounds are classified into two types. One is we can call as a benzenoids. Another one is called as a non-benzenoids. Another one is called as a non-benzenoids. All of you, what are the examples for the benzenoids? Which we can call as a benzenoids now? Any one of them. Now, benzenoids is nothing but the compounds which contains the benzene-like structures are called as a benzenoids. Examples of benzenoids is benzene, naphthalene. All of you know the structure of naphthalene. So this we can call as a naphthalene. Okay, and anthracene. This we can call as a anthracene. Okay, so this we can call as a naphthalene. This we can call as a naphthalene. This we can call as a phenanthrene. That we can call as phenanthrene. Now, all these three are having benzene-like structures. So that's why all these are we can call as a benzenoids. Which we can call as non-benzenoids means here the compounds which does not contain the benzene-like structures is called as a non-benzenoids. The compounds which does not contain the benzene-like structures is called as a non-benzenoids. Example of the non-benzenoids is propylone. Examples of the benzenoids is here propylone. Propylone is a 7-membered ring. This we can call as a propylone. And azulene. What is the structure of the azulene? This we can call as a azulene. So these two are we can call as a non-benzenoids because of they are not having benzene-like structure. If these two propylone and azulene are having benzene-like structures, is they having benzene-like structures? Anjan? What are the examples of the non-benzenoids? Sriveda. But everyone they become dull. Aditi. Aditi, what are the examples of the non-benzenoids?
Sir, any compound, any cyclic compound whose molecular structure, like molecular formula, isn't the same as that of benzene.
Okay, so which we can call as non-benzenoids?
So I don't remember the examples.
No. So what are the examples? I'm asking what are the examples of non-benzenoids? Propylone one. Okay, so one is propylone, another one is azulene. Okay, propylone, LONE. Here, azulene, AZULENE. Okay, these two are the examples of the non-benzenoids. Okay, and sir, the next concept you are asking the nomenclature. So before going to the nomenclature, we have to know some terms. Okay, so what are the terms we have to know means here? Some functional group, homologous series, saturated and unsaturated. Okay, so first of all, what is meant by the saturated and unsaturated, sir? Saturated and unsaturated. What is meant by the saturated and what is meant by unsaturated? Any one of them?
Saturated having single bonds, unsaturated having double bond and
Multiple bonds, sir. Okay, so saturated means if the carbon is having single bonding, that we can call as a saturated. Okay, and unsaturated. So what is meant by the unsaturated? Means the compounds which containing carbon multiple bonds, either it may be double bond, either it may be triple bond. Okay, so what is the best example for the saturated hydrocarbons? Means alkanes. Okay, so what are the best example for the saturated hydrocarbons? Means alkenes. What are the best example for the unsaturated hydrocarbons? Means alkenes. Very good. Alkenes and alkynes. Okay, so same terms you are getting in physical chemistry also. You know, in physical chemistry, what is the saturated and what is the unsaturated? Do you have anyone you having idea? So you're telling that 12th standard. So solutions chapter is that. There again you are getting as a terms of the saturated and unsaturated solutions. Is that clear, Anjan? Even in solutions also we are having saturated and unsaturated. In solutions, what is meant by the saturated, sir? Interlink it is, so that's why I'm asking. In solutions, what is meant by the saturated? Samhita, Aditi, Anjan, anyone? Sriveda? Akshit is not responding, simply attended. Anyway, Anjan, what is meant by the saturated solutions? Solutions is nothing but mixture of components, na? Solutions are containing solute and solvent. Okay, so here based on that, saturated solutions means no more solute is dissolved in the solvent is called as a saturated solutions. Unsaturated solutions means more solute is added to the solvent, that we can call as a unsaturated. So that is different. Organic chemistry is different. In organic chemistry, we are going to study about the carbon containing compounds. Okay, in the carbon containing compounds, in between the carbon, if it is single bond, it is that means that we can call as a saturated hydrocarbons. In between the carbon, if it is having multiple bonds, with that we can call as a unsaturated hydrocarbons. Okay. Next, homologous series. Homologous series. So what is meant the homologous series? No. The compounds are having same chemical properties, but differentiated by one CH2 group. One CH2 group, or what is the molar mass of the one CH2 ma? Any one of you? What is the molar mass? Molar mass of the one CH2?
14.
14 grams, Sanjay. So differentiated by 14 grams, okay, is called homologous series. Sir, what is the example means here? For example, CH3 bond CH2, CH3. And another one is I'm taking as a CH3 bond, CH2 bond, CH3. So first one we can call as a ethane, and second one is we can consider it as a propane. Okay, ethane and propane are we can consider it as a homologous phase. Sir, how you are telling that ethane and propane are homologous phase means? If you see what's the difference it is there in ethane and propane? What's the difference it is there in between the ethane and propane? What's the difference it is there? If you observe clear structure, clearly I wrote as a molecular formulas. Whether what's the difference it is there? We will continue in the next class. I think so. Hope so. You're having next class, huh? Do you have class next?
Yes, sir.
Okay, okay, ma'am. So we'll continue in the next class. Okay. See you in the next. Until here, all of you understood now?
Yes, sir.
Okay. So we'll continue in the next class.
Sir,
Yeah, ma'am. Whether tell me.
nothing.
Okay. So I asked one question, you didn't answer. So I
Yes, sir.
uh,
I am about to answer you
Yeah,
close.
so the answer is CH2.
Yes.
what's the difference in between the ethane and propane means CH2. Okay. So how much molar mass is difference it is there in between two means 14 grams. Okay. Anyway, we'll continue in the next class. Okay. Have a good day all.
Thank you, sir.
Yes.
Thank you.
Thank you.
Thank you, Maveda.